Hi viewers, welcome to Veteach. Today we are going to discuss about heap sort in data structures. Okay, let me tell what is a heap sort, what are the properties of heap sort. Okay, first of all, you can see here a heap sort is performed. In order to perform the heap sort, first of all, the elements should be placed, the elements should satisfy the heap properties. Okay, let me tell the heap properties. Okay, let me tell the heap properties. The heap properties are the heap tree can be said as a max heap tree, and min heap tree. Max heap and min heap. Okay, max heap means a node, the root node, whatever it may be, the root node should be greater than the child nodes. The root node should be greater than the child nodes. Then the tree is known as max heap. If the root node, the parent node is less than the child node, then the tree is known as min heap. Okay, let me tell here in the data structure. Okay, here max heap. Okay, let me show you an example. See the root, the parent node 12. You can see here 10 and 9. So 12 is greater than 10 and 9. So this part satisfies the heap properties. Okay, this is the max heap. Again, consider this subtree. This is the parent. 10 is the parent. 5 and 6 are child nodes. So 10 is greater than its child nodes. So this is the max heap. Again, 9 and 1. Okay, here 9, the child node is 1. This is the maximum node. So this is the max heap. Okay, min heap, as I said, the parent node should be less than its child nodes. 5 and 9 are the parent node is less than 5 and 9. Okay, so this part is minimum. This subtree satisfies the min heap. Okay, and later you can see this part. This is the parent node and this is the child node. This parent node is less than the 10 and 6. So this is also min tree. This part also satisfies the min heap, and this part also satisfies the minimum heap property. What is that? The parent node should be less than its child node. Okay, so first of all, you have to construct the heap tree. In order to solve the heap sort, first of all, you need to construct the heap tree. The heap tree means it can be a max heap or it can be a min heap. Okay, for example, if their elements have given like this, okay, like 5, 4, 9, 2. So sort the elements using the heap sort if the question is like this. Okay, first of all, what we need to do is you have to construct the maximum heap. You should construct this tree. Okay, yes, construction means it should be a complete binary tree. Complete binary tree means left to right. You should construct that elements by satisfying the complete binary tree properties. Like 5 is a root node, 4 and 9 and 2. Okay. So this is what a complete binary tree means. You have to insert the elements from left to right. Okay, fine. Now you should check whether the given tree is a max heap or not. Okay, max heap means what we need to do? We need to check every subtree is satisfying the max heap property. So from bottom level you need to check. So this is the subtree. You can see, so there are no elements. So this is in the max heap. You can see this is in the max heap. This subtree is also max heap. Now consider this whole tree. Now this is not in the max heap. Which one? This one. 5, 4, 9 is not in max heap. Why? Because 9 is max. So whenever the tree is not in max, what we need to do is we need to swap those two elements with the maximum element. So the 9, 4, 5 and 2. Whenever swapping takes place, again you need to check whether each and every subtree is following heap property or not until none modifications are done. And I have been swapped here. Again, you need to check from the bottom level. Okay. So there are no child nodes. Okay, this is in max heap. This is also in max heap and this is also in max heap. See, I have not swapped any element with any more element. So like this, you need to compare the each and every subtree until the null modifications has been done. Then only that given tree is in heap tree. Okay. Now what we need to do? We need to perform the heap sort algorithm. Okay. What we need to do is consider this tree. Okay. 9, 4, 2 and 5. Here we need to delete the node. So what we have done? We have inserted the node into the heap tree. Finished. Now you can see, now we have to delete the node. In heap tree, when you need to delete the node, you should delete the node from the root node. Okay, you should delete the root node. When you delete the root node, you should replace with the child node. Whatever the child node is there, with the last child node, the deleted node should be replaced. Okay. So when you delete this node, who will be deleted, guys? 9 will be deleted and put it into the array. Okay. So write the position 0, 1, 2, 3. Okay. 9 is placed into the array. Fine. Now what I said, whenever an element is deleted, we need to fill that position. With which element we need to fill that position? The last child node. Who is the last child node, guys, here? Who is the last position element? 2. So you need to replace with that node. So the 2, 4 and 5. When you delete that node, deleted node will be stored in the array and the last child node will be placed into that deleted node. Again, you need to check the tree is satisfying whether the heap property or not. Now let us check what I said. You have to check from the bottom. Okay, is 5 is in the satisfying the heap property or not? Yes. Here I am considering the max heap. Okay, you can consider min heap also. Okay, again this is also in the max heap. Yes, here you can see this is not in the max heap. What we need to do? We need to swap the elements. So 5, here 4 and here 2. Fine. Okay, now it is in heap property, heap tree. Now the positions are 0, 1, 2. Again we need to delete the element. Which element? In the heap tree, the node can be deleted only from the root node. Which node will be deleted? Element 5 will be deleted and it will be placed into the array. Okay. Now you can see with which element we have to replace? The last child node. Who is the last child node, guys? 2. So replace with this 2. Okay, 2 and 4. So 0th position and first position. Okay. Is it satisfying heap property? No. So we need to swap with the 4. So 4 and 2. So 0 and first position. If we delete this node, the 4 will be stored into the array and 2 will be replaced with 4. So 2 will be replaced into the 0th position. There are no nodes in the tree. So here you can see the 2 is in the 0th position. Place it into the array. So delete this 2 and there are no more nodes in order to replace. So deleted node will be placed into the array, which will be placed in the 0th position. 0, 1, you can see like this also. So 0, 1, 2, 3. Okay. So this is in the order 9, 5, 4, 2 means I have stored in the descending order. Why? Because I have followed the max heap property. If I follow the minimum heap property, then the elements will be in the ascending order. So 9, 5, 4, 2, which is also a sorted order. Okay. This is how the heap sort works. So heap sort property means the tree should be, first of all, you should create a tree with the elements by following the complete binary tree. Complete binary tree means you should construct from left to right. That is the first thing. Second thing is you should check whether the tree is satisfying the heap property. Heap property means either it is a max heap or it is a min heap. Max heap means the parent node should be greater than its child node. Min heap means the parent node should be less than its child nodes. Okay, so whenever you construct a heap tree, it should satisfy the heap properties, and you need, in order to perform the heap sort, you need to delete the element from the root node. So in heap tree, the deletion operation performs only on the root node. Okay, so the deleted node will be stored into the array, and the deleted node will be replaced with the last child node. So replaced with the last child node into the root node, and check whether it is satisfying the heap property or not. Whether it is not satisfying the heap property, swap with that respective element. So delete that, delete all the nodes in the tree until the tree is empty. This is how the heap sort works. I hope you understand the video. Let us meet in this next section with a new topic.